Hi, this is our video for EA16, the value of the initial blank. In a moment, we're going to sketch a graph showing a linear relationship that does not go through 0, 0, the point on the graph where the two axes intersect, or sometimes it's called the origin. Our question is, what is the value of the axis at the point where the best fit line meets one of the axes in this graph? What meaning does this have? And the experiment that we just did, the effect of mass on the length, or we can call this the stretch length of a rubber band. This experiment is a nice example of this. Most of you who finished this best fit line noticed when we make this graph of length in units of centimeters on this axis and mass in units of kilograms on this axis, even when the mass was 0, the length of the rubber band was not 0. So the graphs ended up looking like this. Some people said, like, hey, maybe is there a curve to this line? And there might very well be, but we're going to have to get into curved lines a little bit later on. Right now, the most important thing we're pointing out is that when the mass is 0 and we're hanging nothing from the rubber band, the length of the rubber band is not 0. And we can obviously see that. This rubber band, it has some length to it, even though nothing's hanging from it. We can also see that the red rubber band and the blue rubber band have a different length. If I start from the same spot here, the blue rubber band is longer than the red rubber band. There's an important difference there. And we're actually able to read this part of the graph to see exactly how long the rubber band is that we're graphing. So we're going to make this note here about this point. That point is special. By the way, if you haven't made this graph already, copy down this graph now. This graph is crucially important for us in order to understand what we're writing over here. Don't just write down the words, write down the graph also. And we're saying the quote-unquote initial length, which is right there, the initial length of the rubber band shows its length before any mass is hung. And you probably know this from y equals mx plus b. In math, on a graph of y and x, the point where the line meets the y-axis is usually called the y-intercept, or initial y value. In science, we want to be more specific. So we give this point a name that's specific to the axis. So we're calling this the initial length. But we do want to make a note that you can use what you know from math class. So let's make that note here. The initial value, quote unquote, the initial value with units, always, any number that we write down has units, is the b in y equals mx plus b. I know that you've done a lot of work with y equals mx plus b in math class, and we're going to be using that in science class with some important differences. But we need to make sure that we know that that b has real meaning for a lot of physics situations. So, for example, some groups calculated today that the slope of their graph was equal to 24 centimeters per kilogram. The slope is this m number. And some people calculated that the initial length of their rubber band was 39 centimeters. So that would be the B. So we've got information about the slope, how the rubber band changes length when we add mass, and the rubber band stretches out like that. And the initial length, what the length of the rubber band is before we do anything at all.